Geometry Unit 6, Section 6, dividing a segment into equal pieces. So in this video, you're going to learn two different constructions on how to divide a line segment into however many pieces you want to divide it into. This first example, we want to divide it into 3 equal pieces. So we want to divide it into thirds, like 1, 2. You know, obviously it's going to be way more accurate than that. But we want to divide it into 3 sections. This one, we want to divide this one into 4 sections. But there's 2 different ways to do this. We call them the side splitter method and the dilation method. The dilation method involves a given parallel line. The side splitter method does not. Now, you could always construct a parallel line and then use the dilation method, but you're going to see that they're kind of similar in that way. And to take the time to create a parallel line, well, we're actually going to be creating parallel lines anyways, so you know, you'll probably be tested on both of these, so you need to know them both, but they both accomplish the same goal. And on a Regents, I doubt they would say you have to do one or the other. It's probably whatever. But again, this one, you need a parallel line to do this one. This one, you don't. So this one's probably a little bit more useful because you don't need any other given information. You could just have a line segment, and you could divide it into 2, 3, 4, 5, 6 pieces, however many you want. So the way we start this off is we draw a transversal line. So just go from one end of your line segment, we'll say point A, and just draw a line at really any angle, you know, maybe somewhere around 45 degrees, something like that, but it doesn't really matter. Just make it big enough like that. I wouldn't go too tight because then it's going to be too small to work with, so this is a good angle right there. And what we're going to do is, first thing we're going to do is we're going to not divide, but we're going to split this auxiliary line into 3 equal pieces. And I'm just going to pick a length, kind of like I picked any random angle. Pick a length, something reasonable, something like that. And I'm going to do it in 1, 2, 3 pieces. And I'm going to have some extra off on the end, but that doesn't really matter. Just however many we want to do, 3, 4, 5, make that many slashes on your auxiliary line. Okay? Your last slash, the third one. So 3 pieces, it's going to be my third one. If I were doing 5, it'd be my 5th one. If I were doing 2, it'd be my 2nd one, so on. My last one, connect that to the other end of your line segment. So connect that to B. And what we did is we basically created a triangle. So now, what I'm going to do now is I'm going to use the copy angle construction to copy this angle here. Whatever this angle is, I'm going to copy that to here and here. And where they cross, that's going to divide this line segment. So it's a copy angle construction that's very useful. So let me show you how to copy this angle here. All right, so start off by drawing an arc. And I'm going to draw that arc at my other slash points. Now I'm making it plenty big. Okay. As I'm copying this angle for as many other slash points that I have. Next, after we draw all the arcs, we now measure the separation in the arcs. And the way we do that is my arc hit both pieces of my angle. I put it at 1, and then I need to move my compass so that it is the separation length there. Let's see, I need to make this a little bit smaller, and I'll do this in, let's say, red. All right, so that right there. And you always have to make that slash showing that you measured the separation. And now I need to do that same thing here with the same slash and the same thing here. Slash. So we copied this angle for all of the other original slash marks here. We can put points here if that's helpful so we don't confuse the arc and the point and stuff like that. Okay, next, now that we copied the angle with the original arc and then measured the arc, now we connect lines there and extend it all the way down so that it hits your original line segment. Same thing here. From there, extend it all the way down. And that's it. Take a look now at AB. We get a point here. and a point here. So 1, 2, 3. That these are 1, 2, 3 equal pieces. We divided segment AB into 3 equal sections. So what we did was we actually created, these lines are parallel, because copying angles creates parallel lines here. That's why I called this original line a transversal. So the first thing is just draw that transversal and just mark it off at really any length that you want, but something that's, an average length, into 3 sections or whatever this is. Last one, connect down, and then copy that angle at the other slash marks you made. And extend those, copy that angle, extend it down where that hits here. That's going to work out. Because I know these 3 are equally spaced, and I know these angles are congruent. So essentially what I've done is created a bunch of dilated triangles with congruent angles, and if these are equally spaced, that means these have to be equally spaced because of the side splitter theorem that we learned in our previous video. So that's how you do the side splitter method. It's probably one of the more advanced constructions we have all year, so it's going to take a little bit of practice to do. We'll practice that a few times. The dilation method is definitely much easier, but the problem is you have to be given a parallel line. Now, like I said earlier in the video, I could create a parallel line here and then do this, but if I'm creating one parallel line, I might as well create all of them and just do this. But this is much easier to do. So what we do for the dilation method is, all right, I want to do 4 pieces here. You got to know that. Now, the segment I'm trying to divide is CD. That's a line segment. Line L is not a line segment. That's why it has an arrow down here. I can make this, and I can extend this if I want. I make it as long as I need. But we are going to start by putting slashes on the line L, not the one we divide, the one we're using as the parallel line. And much like what we did with the transversal, where I just kind of pick a length and mark it 3 times, that's what I have to do here. I'm going to pick a length and mark it, but this time 4 times. But what really makes this helpful is I would like my 4th slash to be further than point D. Like, I don't want my last slash to end here. I want my last slash to end somewhere beyond where D is. Like, over here would be great. And you'll see why in a little bit. It's not vital, but it'd be very helpful. So just kind of, I'm going to see how this works out. And if I have to erase it, I'll erase it. So maybe do this one in pencil. So I'll mark it 1, 2, 3, and 4. And I just had enough. Like I said, I could have extended this line if I didn't have enough space. But you see how my last one ended up beyond D. So this is pretty far beyond D. I didn't have to go this big. But here's my 1st, 2nd, 3rd, my 4th one. And put points for all these slashes. It's always a good idea to do that whenever a slash hits a line. Okay. Connect your beginning of line L, just want a line, to the beginning of your line you're dividing, but extend it all the way out. And then connect your last slash to the end of the line segment. Extend it all the way out. Where they cross is going to act like your center of dilation. And now all we have to do is connect that to your other slash marks. Just like that. And so if we take a look at line segment CD in here, we have 1, 2, 3, 4 equal sections. So that is much quicker than what we did up here of copying an angle a bunch of times, but it does essentially give you a similar looking picture, and it works out to be the same thing. So CD was split up into 4 sections here. All right, so a couple of different ways to divide a segment here. We'll practice both of these, and these are probably some of the most advanced constructions we're going to see in this unit. So definitely take care with them, be as precise as you possibly can. See ya.